50 years of European space exploration, half a century of ideas made real, of daring missions, and we're here at ESA's ESTEC Open Day for Space Rocks. Stay tuned for Robodogs, Noordwijk's Walk of Space, interviews with ESTEC scientists and crew, and a sneak peek at a mysterious specimen.
My name is Dietmar. I am the director here at our ESTEC establishment here in Noordwijk in the Netherlands. And I'm also super proud to be the one who is actually hosting this fantastic open day here in 2025.
As you should be. This is just so wonderful. So this has really become a highly anticipated date. How does it feel to be back here again, having the opening ceremony and welcoming everyone back to ESTEC?
It's fantastic. We never sell our tickets, we give them away, but this year 12,500 tickets were given, and I think the first batch, they were gone in at 1 hour, 45 minutes or something like this. So it's really becoming a big, fantastic event, and we're very, very proud of. And I'm always saying the best part for me is, of course, also to see all of the volunteers here, just to show how excited they are about the things they do and want to share it with the public. It's fantastic.
It's a real testament to what you guys are doing.
This is a very special occasion. It's the 5th time that we have an open day also for people with a handicap. This is very important to us at European Space Agency because we are about inclusiveness, about equality, and making sure that people of all natures and all kinds and all abilities have the possibility to see space but also to work with us.
So I've been told that the open days were very much your brainchild. Yeah. So did people think you were mad when you suggested opening a secure facility to the public?
I think the first motivation was, here you have 3,000 people, the largest space technology center in Europe, and nobody knows about it. It's like ESTEC was the best kept secret of the Netherlands. Most of all these people around are paying taxes which keep us going. So let's get these people in to see what we do and see what ESTEC is. If you want to know a lot about space in one day, come to the ESTEC Open.
I've been saying the same things to my friends. You should come. You should come. It's brilliant.
It's the easiest way to get a view of what space is and does.
I'm Rosemary Coogan. I'm an astronaut for the European Space Agency, for ESA, and I was selected in 2022, so I'm very much in training at the moment. Had about 2.5 years of training so far, and really happy to be here today.
And I'm Jeff Wayne, and I'm a composer, producer, conductor. I have a work known as The War of the Worlds that seems to have aligned me in some degrees with
just a little.
ESA.
You're both absolute celebrities. My opening question was a bit of a joke because I've seen Rosemary having as many people asking for autographs and photos as you have.
I'm not surprised.
How does it feel to be recognised by a community that's actively trying to bridge science and creativity?
I do think music, the arts, and storytelling, and particularly science fiction, they very much aligned with each other. I think if you're into music, as I am, and creating things, you need a sort of adventurism to explore where, in my case, I've never gone before, to paraphrase a well-known phrase. And I think conversely, and probably more on a serious nature, people like Rosemary, who's attempting an adventure into space, those are the real heroes because they are going where no man has ever gone before.
Yeah. And relying entirely on each other. I just find the whole thing so incredibly inspiring. Which brings me on to your good self, Rosemary. So when you were selected, obviously that would have been a huge inspiration to so many people. What ideally would you like your journey to send?
I think it's incredibly important to send the message that space is for everybody, and I think this really, it goes beyond gender. You know, it's really, we're seeing more and more in the selection process now for astronauts that it's not just the typical backgrounds that you get. You know, we need all different types of people in space. We need people to have different opinions, to approach problems in different ways. And absolutely, you know, anybody who is interested in space should absolutely go for it, because we need a rich team. That's what we're building here. And I would love the selection of 2022 to help send that message and to continue to inspire people, just as I have been inspired for many years. I think it's an incredibly exciting time to be working in space, because we are having so many new things. You know, we're for the first time going beyond the International Space Station to actually having commercial stations, seeing how our relationship in commercial low Earth orbit will work, what that means for science and for astronauts. Of course, we're going back to the moon, and next year already we'll have the ESM powering the first crewed mission back around the moon. And, you know, we are going to learn so much from that. It's really going to bring us further and further afield into the solar system. And I just feel so passionately that, you know, space is part of who we are, and we should absolutely be exploring that. And I can't wait to see how that technology brings us further and further to learn about ourselves and what we can do.
My name's Alan Dowson. I work in Tech MMG, and we are here in the Life and Physical Sciences Instrumentation and Life Support Laboratory.
Wow.
Big name.
That's a lot.
Yes,
Yeah.
It is. Yes, we just shorten that to the LIS Lab. The room behind us is the clean room. It's one of the cleanest rooms in Europe. It was built for precision cleanliness in relation to planetary protection. Mm-hmm. So this clean room here performs cleanliness and sterilisation, so that when we deliver items to the ExoMars rover and it lands on Mars, that we don't have taken any
Cool.
items with us.
But the thing is, when you hear about the clean room, you think, oh, it's for things that we're bringing back. It's for things that we're bringing back from missions and making sure that I hadn't even considered the other way around.
No, yeah, you're right. I mean, it is for both, actually. Planet protection is for both ways. So for my sample returning, you know, it would also take that into account. At the top here, we have ultra HEPA filters, and each one of these squares has a filter fan unit on top, and the air flows straight down directionally. So when we are inside, the particles that you shed fall off you and go through the floor.
Oh my gosh, that's
and
amazing.
And then back through this gap, and then recycled 80% with 20% fresh air. So the clean room's clean, but as soon as we go in, we contaminate it. So that's where all your procedures come in. And even with your full gowning on, you still produce particles. And the reason we are interested in particles is because bacteria and fungi, they don't actually float about in the air. They move about on particles. So if you reduce the particles,
I see.
you reduce the chances of contamination.
Today is really a big honor for me. We planted the imprint of my right hand here on the boulevard at Noordwijk. Yeah, we see here imprints from 20 astronauts who all have been to space. Even one of them has been to the moon. Talking about the moon, this was one of the big moments in my early childhood, which really was decisive to want to become an astronaut. And I mean, at that point, I couldn't really see that this ever would happen, but it definitely triggered me. And of course, today we are hoping that we will see, maybe before the end of this decade or beginning of next decade, a European astronaut at least flying around the moon or even leaving his or her footprints on the moon. So, you know, that closes a little bit the circle.
What role is ESTEC currently playing in humans getting back to the moon?
We have here in ESTEC our moon team. Our moon team is preparing the first European lander to land safely on the lunar surface. We are building from here the European contributions to the Gateway, an outpost around the moon. You will see the moon in a never seen way as before. Really amazing. So a lot of things coming up to change the destiny of this continent.
And what are you hoping that these upcoming missions will ultimately teach us?
As Europeans, we are not going there just to put the flag. That's exactly not what we want to do. We want to do science. We want to understand where we go. You have to imagine that when I will sign off to have one of my team members sitting on top of a rocket flying to the moon, I want to be sure that this team member has a chance to get home. It's even more true when we speak about Mars. It's nice to have dreams, but we want to understand and characterize the environment where they go. We want to see what enabling technologies we still need, what we need to understand scientifically to have them in a safe environment. And again, we need return tickets for them as well.
Yeah, 100%. Can you tell us, where are we and what are we looking at here?
What matters here is just 50 years of evolution of computers at ESA, from different way of computing stuff, different way of interacting with the computers, different size of computers, different kind of power they use, and how they were used basically. This smartphone has basically more computing power than these two towers that were used 25 years ago to simulate the robotic arm on the ISS with the astronauts when they were training.
My gosh. That's astounding.
So yeah, just to show that there's been a lot of evolution in the past 50 years, and that's the whole history of this place.
I'm Claude Licolier. I was a Swiss ESA astronaut. In fact, I was in the very first group that was selected in 1978, so a long time ago.
So you've spent a lifetime pushing limits. What drives you to still look to the sky, to still look to the stars?
Well, the drive is passion. Passion for space, passion for astrophysics as well. That was my first job. Passion for spaceships, for airplanes, for stars and for galaxies. And in a way, my whole life has been devoted to work in these areas.
Yeah.
So I've been very happy doing what I had a passion for.
That's so cool. So 4 missions, 1 legendary Hubble repair, I understand. When you look back at your career, which moment gives you goosebumps?
Well, there was so many very special moments. I have to say that as a former astrophysicist, having become an astronaut and going to Hubble was a dream, especially the first mission, because for the first 3 years, as you may know, the telescope was basically not seeing very well because of a faulty shape of the primary mirror. And it was put to orbit in 1990, and the first time we went there was end of 93. So for a little more than 3 years, it was not seeing very well. Wow. So we had to go and fix the optical problem, and we installed optical correctors so that for each of these instruments, either cameras or spectrometers, the pictures were sharp again. That was quite a tough mission, because we never previously had gone to do major repair work on a complex scientific instrument in the space environment. Work in the space environment is tough, you know. It's vacuum, of course, you have your spacesuit, but it's also weightlessness, which makes it difficult to work at all.
I can't even imagine. And what was it like doing that repair with the world watching, essentially?
Well, it was a big load on our shoulders, because NASA told us failure is not an option.
Wow.
Because there was an embarrassment of having let the telescope put to orbit, and I was privileged to be part of the team for the repair, but it was a load on our shoulders. We needed to be successful, and we were eventually.
I mean, that is real pressure.
I'm Sant, and I work here in the Human-Robot Interaction Lab, and I'm a software developer. We develop software for robots that go to space in the future. And what we want is we want to keep the human in the loop. We want to be able to control robots in space, but the human is either on Earth or is in a space station, such that the controlling is from a very large distance. We want robots on the moon, for example, to explore, to collect samples that can go back to Earth, or maybe even build a moon base, for example, in the future.
Wow.
Yeah. A frequent asked question is how we deal with delays, because it's such a big distance between the operator and the robots itself. So the data needs to travel a long distance. We know that from the International Space Station to the Earth, it's less than a second. So it's still quite short, and we can still work with that delay.
Less than a second? That's amazing. What are the chances of the robots taking over? Come on, there's got to be a very slim chance.
I think if you come more often to the lab, you also see the robots failing many times. And of course, we try to make them know their own mistakes so they can recover themselves. But we see so many times that they still fail, and I think that's also why we need the human to help them not failing. But I think we're not there yet that they will take over.
As long as they're failing rather than feeling, I think we're all happy. Everything will be fine. So how important would you say sci-fi is in sparking the imagination of young astronauts, young scientists?
Absolutely. It's what made me a big fan of science. It was the science fiction that started it with me. And then I had a science teacher, and he was talking about the speed of light and supernovas, and then I was hooked. And so science fiction was for me the basis.
And what advice would you give to any young scientists watching this now, wanting to follow your path?
First of all, follow your dreams. Never tell yourself that you cannot do it. Imagine where you want to be in 10 years and start now and make the steps. Do something that you like, because you're probably good in it then. So that's an important one. Technology, science, and then just follow your dream. Never say never.
What inspired you guys to set Andre in some kind of carbonite?
It all happened one night when I went to go with my dad to the pub, and we were discussing what we were going to do this year, and some ideas came up, and one of them was this.
It's been so fun creating it. Like, a lot of weeks have gone through this, and it was just the connection of real science talk about hibernation of astronauts for long trips, and the fun of Star Wars and everything that represents. Even the patches and everything are specially designed. The LEDs on the side are Morse code with names of legends from the group. It's so nice.
I love that, the detail. That is so cool. And how did it feel to see him seeing this for the first time today?
Very nice, because I think he liked it, and we loved making it. So seeing people love seeing it, it's amazing.
I'm impressed, because it was not obvious to make it, of course. But I must say the result is fantastic. I love it. Very nice.
Hello, David. Thank you very much for joining us.
Pleasure indeed. I would not have missed it for the world.
So we're
for the universe.
Yes, we're going to talk about science and science fiction. Were you always a fan of science fiction?
Some of my earliest memories are hiding behind the sofa, watching Doctor Who, and trying to build sonic screwdrivers and Daleks out of cardboard boxes.
Why do you think there is such a symbiotic relationship between science and science fiction?
For me, the best description I heard was a guy who built brain-computer interfaces. And he said that science fiction is the first stage of engineering. It's the dreaming phase. And I thought, that's so stuck with me, because once you hook onto something, you get an idea, the first thing you have to do is imagine where you're going to go with it. And that's what science fiction is. Originally, it was science, but a fiction. I mean, it's become much more sort of fantasy and otherworldly. But at the core, science fiction was about, like, where could we go with science? That was the question. And I love that type of science. Always been a fan of that. I mean, I love the fantasy and losing myself in other worlds. But when there's a little bit of grounding there, where I go like, ooh, there's a little kernel of truth there, something I could learn, that blows me away. Like
That is very cool. You were in one of the biggest sci-fi franchise of the last several decades. But if I can be controversial, if I were to ask you to pick another franchise that you would like to be in, is there one that jumps to mind?
There's a million. I mean, I would love to do any of them, honestly. I mean, obviously Star Trek, because of I love its grounding in science. But, I also, I remember going to the theater and watching Star Wars, and I just think, oh my God, to be a part of that universe. But the first big science fiction hook for me was Doctor Who, and oh my God, I always wanted to be Doctor Who. That was my dream. So,
hopefully Russell T Davies watched this and cast you.
My name is Sarah Markhoff, and I'm an astronomer, astrophysicist at the University of Amsterdam. But I'm also part of several big collaborations that basically take data in different wavelengths. And one of them is the Event Horizon Telescope, which also did the first pictures of the black hole.
Gotcha. For someone new to this, how would you describe the death and rebirth dance that happens around a black hole?
It depends on which kind of black hole you're talking about, actually, right? Because some black holes do die and get reborn as black holes from basically very large stars. And so that's what happens when you have stars that are, extremely big, much bigger than our sun, and they die in this glory that we call supernova, and then they compactify down, fall into their own event horizon, basically. everything has an event horizon.
yeah.
It's just most of us live
Wowzers.
outside of it.
Yeah, thank goodness. Yeah.
And it sort of goes down, and then you end up with a black hole remnant. But a lot of the black holes that we see, mostly in the centers of galaxies, and we think every galaxy has one, these are what we call massive black holes or supermassive. We actually are not entirely sure how they form. They could have started from early seeds from big stars that maybe died much earlier in the universe and were hundreds of times bigger than the sun, but the new results from JWST are challenging this, and there's a lot of questions about maybe somehow they were primordial and somehow formed with the Big Bang, and then just got fatter and fatter as the universe grew and they ate. Yeah,
I love that.
It's a big field in development at the moment.
What you've done for your career is essentially stare into the void, which is like the most rock and roll thing I've ever heard. It's so cool.
It's funny, people say that. I find that interesting way of thinking about it. Like, maybe it has to do with not being afraid of the unknown. I think the more mysterious something is, the more, you're talking about literally some kind of rip or tear in this fabric of space-time. Not exactly, but something is going on there that we don't understand. It's telling us about really where quantum mechanics meets gravity. There's no theory at the moment that links these two scales, and somehow black holes maybe hold the key to it. So so many people are interested in these for different reasons, but there's a lot of sci-fi. I'm a sci-fi geek. I like the fact that I'm doing sci-fi for a living.
My name is Ulf Merbold. I'm a physicist, and I was picked amongst the first 3 astronauts to train for Spacelab 1, and I was the lucky one who got the first mission. I became the first ESA astronaut who made it to orbit.
It's fantastic. Is there one real shining moment from your incredible career that really comes back to you regularly?
There are many moments, but if I focus a little bit on the programmatics, then I think I'm proud that I could contribute to ESA's success as a player in manned spaceflight. ESA took the decision to make a contribution to the shuttle program, and that contribution is Spacelab. And not only on the maiden flight where I was involved, it worked flawlessly. It was in orbit at least 20 times and always worked without any trouble. So that was in a way the starting point for ESA, for us Europeans, to be recognized as competent players in manned spaceflight, and so we got the invitation to participate in the ISS program and now in Orion. And I think Spacelab, in a way, is a key moment for Europe as regards manned spaceflight, and I was part of it. So that makes me very happy.
As it should. Very proud indeed.
My name is Laura Thijs. I'm fashion designer and costume designer, and from now on also space designer.
Yeah. We're going to talk about some of the incredible fashion that we've got on show. First and foremost, what is it made of?
These are recycled satellite materials, MLI foil and even real gold.
Oh my goodness. They send gold into space?
They do. I was shocked like you are. As a fashion designer, I'm always looking for new inspiration and new ideas. And I thought, yes, maybe I can bring my part into the space and do something and try to recycle those materials.
The recycling is a fundamental element of our future space missions. You want to live on the moon, you cannot bring all the materials from the Earth. You need to use the materials that are already on the moon, and second, you need to recycle materials as much as possible, to the point that we want to use the satellites that are on the low Earth orbit. We have 3,800 non-operational satellites that are just wasted there. The intention is to bring them to the moon and use those materials as construction materials for building the moon base we are going to build on the moon.
Or fashion.
Or doing fashion.
Or both.
Exactly.
Or both.
I'm Gaetan Piret. I'm working at ESA as head of the test center here in ESTEC Noordwijk.
And we are in something that really does look straight out of science fiction. Never mind what's going on here. But what happens here?
So this is the LEAF, standing for Large European Acoustic Facility. This is the place when we try to reproduce the same sound as a rocket
to make sure that the satellite which is sitting on top of the rocket will survive the vibration of the launch.
Wow. What would you say is the weirdest thing that you've ever had to test or use in this space?
Well, the heck next to us.
That's definitely a good, good start.
Unexpected. We don't used to see this type of specimen. We are more used to high-tech satellite rather than science fiction items.
What would you say is scarier, space itself or the things that we imagine live in it? I don't think I'm going to like this answer.
I think probably the thing we don't know about space is the more frightening things. Now with satellites, rockets around the Earth, we are controlling very well, but what is beyond is probably the most fearing things.
Utterly unnerving.
My name is Michelle Doherty. I'm the principal investigator on the magnetometer instrument on the JUICE spacecraft. So that's my link to ESA. I've been working with ESA for 30 odd years.
Awesome. And tell us a little bit more about JUICE.
So, JUICE is called Jupiter Icy Moon Explorer. JUICE was launched in April 2023, is on its long, slow route out to Jupiter. We have 1 Venus flyby, 3 Earth flybys before we finally go into the outer solar system. And we do that because we can't launch with enough fuel to get us straight out there. And the focus for JUICE, it's going to study the Jupiter system, but for me the unique aspect is it's focusing on 3 of the moons. Europa, we have 2 flybys. Callisto, it's about 26 flybys. Ganymede, we've got about 20 flybys, and then at the end of the mission we're going to go into orbit around Ganymede. And the main drive behind JUICE is to understand whether there's the potential for life to form in the liquid water oceans of the Jovian moons.
What a fantastic mission.
I've got to pinch myself when I think about we've actually got this on the way out there.
Yeah, and the fact that it's going to be the first mission to enter orbit around the moon that is not our own.
Absolutely.
Incredible. There are some upcoming observations from JUICE which are very exciting.
We are going to take observations on the 2nd of November. So all the remote sensing instruments are going to focus on 3I Atlas. One of the cool things though about the timing is that's when the comet is very close to the sun. And so we will see the tail of the comet, we'll see it evolve as well. And then again on the 25th of November, we will take a lot more data. We're further away from the sun, we can leave the instruments on for a bit longer. And then again compare to the observations we had on the 2nd of November. But isn't it great? You've got a spacecraft out there wending its way to Jupiter, and then this new interstellar object pops up and you think, why don't we have a look at that, huh?
It's amazing. It's absolutely amazing. One final question. Is there something you would like the general public to know about JUICE?
Because it takes such a long time to do these things, the kids who are at school right now are going to be the people doing their PhDs on the data. Really want to involve the younger generation because they're the ones who are going to take us forward into the future.
Well, let's get the younger generation involved.
Absolutely.
Thank you very much.
Thank you very much.
I think it's fundamental to share with the public what we do. We do so many amazing things. We have wonderful spearheads of space in Europe, but it's not only the astronaut, but there are also a lot of engineers, of scientists doing projects which are at the limit of what we can do. It's really technological innovation, it's scientific excellence.
I'm Florian Klövekorn, I'm from Germany, and I'm a physics teacher.
To any young scientists out there, what advice would you give them?
Stay on it. If you think that's your thing and you love it, stay on it. Don't do something else. That's the most important thing. If you just love something, you don't have to work actually, because someone will pay you for something you love. That is the optimum you can get.
Absolutely.
You don't have to be the very best mathematician. You don't have to be the very best physician, but a certain knowledge, passion is good. And then combine this with, I want to be in space. I want to be part of these missions. That's exactly what we need here. And to bring, again, all of these great spacecraft, satellites, launchers into space.
It's not easy to be a concert pianist or a top artist or a sports, person.
Absolutely.
It just takes dedication. You have to have that passion for doing it. So if science is your passion, you will get there. You just follow what you're interested in. It doesn't really matter who you are.
Thanks for watching and stay tuned for more Space Rocks.